Welcome student, and continue beta and gamma functions. We already know what is the definition of beta function and gamma function. So without fail, you have to remember here the definition of gamma function as well as definition of beta function. So second definition of beta function as well as the properties of beta and gamma function. So all properties of beta and gamma functions you remember here. And with these properties, continue beta and gamma functions, means examples on the beta and gamma functions. With these properties of beta and gamma, so continue beta and gamma functions, means examples on beta and gamma functions. This is the second lecture on beta and gamma functions, so you must watch the first lecture of beta and gamma function. Then only you will get easily what we are doing during this lecture. So example on beta and gamma functions. So evaluate integration 0 to 1 x cube into 1 minus under root of x whole raised to 5 dx. So how to evaluate this? You just remember here, when any example in the beta and gamma function, first you relate to either the definition of beta and gamma function or property of beta gamma function. So here if we relate this example to the definition of beta function, so you can see what is the definition of beta function: integration 0 to 1 x raised to m and 1 minus x raised to n, or n minus 1 m minus 1 dx, and that is nothing but beta of m. So here x cube single, okay, 0 to 1, that is also okay, but 1 minus here I want variable with power 1, means just like x raised to 1. So that is why this definition of beta suggests us the substitution. So before to that, you just consider it is integral I. So let I equal to integration 0 to 1 x cube 1 minus root x raised to 5 dx. So it suggests us substitution is a root x equal to t. So what is this one? Squaring on both sides. So I am getting here. So x equal to t square. So always you find value of dx first, and that is why x. So dx is what? Differentiate. So I am getting here 2t dt. What about the limits? X to t. Here x 0 to 1. So if we put x equal to 0, so I am getting t equal to 0 and x equal to 1. So under root of 1 is 1. And therefore, this integral I becomes now limits no change 0 to 1. Integration 0 to 1 x cube. So what is x here? T square. Cube of it into 1 minus root x. Root x is a t raised to 5. And what about dx? It is a 2t dt. So simplify now. You take constant term outside. So 2 is a constant term, that is outside. Integration 0 to 1 t raised to 6 into 1 minus t raised to 5 into t dt. Simplify it now. So I equal to 2 integration 0 to 1 t raised to 6 here and one more t. So power of t is a t raised to 7 into 1 minus t raised to 5 dt. As we know the definition of beta function, that is whatever the power of this one. So power plus 1 and this next power plus 1. And that is why I am getting here I equal to 2 into beta 8 and 6 power plus 1 power plus 1. So as we know the relation between beta and gamma function, that is the beta of mn equal to gamma n upon gamma m plus n, means gamma separation upon gamma addition, and that is why I am getting the value of this is nothing but 2 into gamma 8 gamma 6 upon gamma 14. As we know gamma n plus 1 equal to n factorial for n is integer, and that is why I am getting answer here. So I equal to 2 into 7 factorial into 5 factorial upon 13 factorial. So by calculator I am getting here 1 upon 5148. So answer I equal to 1 upon 5148 is your required. Now the next example, evaluate integration 0 to 2 x cube into under root of 2 minus x. Again, as we know, the beta of mn equal to integration 0 to 1 x raised to m minus 1 and 1 minus x raised to n minus 1 by definition. So here I want 1 minus x, right? So that is why you have to put this x such that I should get here 1 minus maybe the new variable t. What is the solution? Let I equal to integration 0 to 2 x cube into under root of 2 minus x into dx. So I want here 1 minus maybe x or new variable t. So how? So you can observe here, that is a x equal to 2t. So I will get 2 minus 2t. So 2 common. So that is why substitution is what? X equal to 2t. So what is the dx? That is equal to 2 dt. And what about the limits from x to t? Given limits 0 to 2. So when x equal to 0, so I will get t equal to 0. When x equal to 2, so this 2 by 2 I will get here 1. So t equal to 1. And that is why this integral becomes now integration 0 to 1 x cube means 2t cube, and here under root, it means that 2 minus what is x? It is a 2t. Under root means it is a power half, and dx means 2 dt. So simplify this now. How? Take constant term outside. So I am getting here 2 cube. Here 2 raised to half because 2 common, and raised to half, and here one more 2. So 0 to 1 integration. It will be t cube and 1 minus t raised to half dt. And then by definition of beta function, this beta of mn equal to this one. So power plus 1, next number power plus 1. So I am getting here I equal to, what is up here? 2 raised to, so here 3, here half, and here 1. So 3 plus half plus 1. So I am getting here 2 raised to 9 by 2 into beta power plus 1 means it is a 4, and next this power plus 1, it is a 3 by 2. So again by relation between beta and gamma function, I am getting here this 2 raised to 9 by 2 as it is. Here gamma separation upon gamma addition means here 4 plus 3 by 2. Now simplify it. So I am getting 2 raised to 9 by 2. This gamma 4, gamma 3 by 2 upon gamma 4 plus 3 by 2. It is a gamma 11 by 2. I equal to 2 raised to 9 by 2. This gamma 4 means 3 factorial. Gamma 3 by 2 means 1 by 2 into root pi upon gamma 11 by 2. It means that it is a 9 by 2 into 7 by 2 into 5 by 2 into 3 by 2 into 1 by 2 into root pi. So I equal to, so simplify it. So this root pi get cancelled. So by calculator you can find this value, or by simplification also. So simplify this. So I am getting this 2 to get cancelled, this 3 also get cancelled, and here power of 2. So I equal to 2 raised to, here 9 by 2 and here 5 means 19 by 2 into 1 upon 9 into 7 into 5. It is a 315. So your answer is 2 raised to 19 by 2 upon 315. So which is your required answer. But one may simplify more. This I equal to, here 2 raised to 19 by 2. I can write it as a 2 raised to 9 plus half. and that is why what is the 2 raised to 9 into 2 raised to half. So 2 raised to 9 is 512. This is the root 2 upon 315. So which is your required answer. Now consider one more example on this. Prove that integration 0 to 1 x raised to m minus 1 into 1 minus x square whole raised to n minus 1 dx equal to 1 by 2 beta of m by 2 and n. So very simple example. In this beta and gamma function, you must remember the substitution. How? See there. If there 1 minus x raised to n, then you substitute x raised to n equal to t or x raised to n equal to sine square theta. Because if I am using here 1 minus x raised to n and x raised to n equal to sine square theta, so I will get here 1 minus sine square theta and it will be cos square theta. And here if I am going to put here t, so I will get 1 minus t and I can use directly beta function. But if I am using this one, so which formula or relation I have to use here? So here you have to use the property of beta and gamma function, that is the sine theta raised to p cos theta raised to q d theta, where integration 0 to pi by 2, and that is nothing but 1 by 2 beta of p plus 1 by 2 q plus 1 by 2. So by this property you can solve when I am using or I am going to convert into sine or cos. If here 1 minus x raised to n means any power of x here. So I will substitute here a x raised to n equal to t or a x raised to n equal to sine square theta. B minus x raised to n, then substitution will be x raised to n equal to bt, and here x raised to n equal to b sine square theta. Similarly, if supposed to be b minus a x raised to n, then a x raised to n equal to bt, and here a x raised to n equal to b sine square theta. Means you can use this one or this one corresponding to these one. Also, if supposed to be instead of minus, if plus sign is there, so 1 plus x raised to n. So here I am getting x raised to n equal to t, and here x raised to n equal to tan square theta. Note the change here, that is a 1 plus tan square theta, it will be sec square theta, and I can convert sec square theta as a cos square. If 1 plus a x raised to n, then a x raised to n equal to t or a x raised to n equal to tan square theta. Next is a b plus x raised to n, then substitution will be x raised to n equal to bt or x raised to n equal to b tan square theta. And if b plus a x raised to n, then substitution will be a x raised to n equal to bt or a x raised to n equal to b tan square theta. So you must remember this type of table for the beta and gamma functions. So consider example here, that is the prove that integration 0 to 1 x raised to m minus 1 into 1 minus x square whole raised to n minus 1 dx equal to 1 by 2 beta m by 2 comma n. So it is very easy or simple example. How? Solution. You consider here I equal to integration 0 to 1 x raised to m minus 1 into 1 minus x square raised to n minus 1 dx. So it is very clear by the definition of beta, 1 minus I want a single t, just like a t, means power should be 1. So here x square, so substitution is x square equal to t. So put x square equal to t. In beta and gamma function, you remember their substitution part is very important. If we are able to substitute the correct thing, then it is very easy by using the properties of beta and gamma function or definition of beta and gamma function, evaluation of that particular example. So what is value of x? You always find value of x, so t raised to half. So what is the dx? It is a 1 by 2 t raised to minus half into dt. What about the limits? Here x to t, 0 to 1. So x equal to 0, I am getting t equal to 0, x equal to 1, t equal to 1. So therefore, I equal to integration 0 to 1, x is what? T raised to half whole raised to m minus 1 into 1 minus x square means t raised to n minus 1 and dx is 1 by 2 t raised to minus half dt. Now simplify it, take constant term outside. So 1 by 2 is outside, integration 0 to 1. What is the power of t now? Here t raised to half raised to m minus 1. So I am getting here 1 by 2 into m minus 1 this power, and one more power of t there is minus half. So minus half here. So what is the power of this one? So it will be 1 by 2m minus 1 by 2 and minus 1 by 2. So it is a m by 2 minus half, it is a minus 1. So that is why I am getting here power of t is m by 2 minus 1 into 1 minus t raised to n minus 1 and into dt. So by definition of beta function, I am getting here I equal to this 1 by 2 as it is here beta power plus 1. So because t raised to m by 2 minus 1, so power plus 1 I am getting m by 2 and here n minus 1 power, so that is why n. What is the I? I is integration 0 to 1 x raised to m minus 1 and 1 minus x square raised to n minus 1 dx, and that is equal to I am getting now here 1 by 2 beta of m by 2 comma n. What we want to prove? So you have to prove same, right? So which is your required answer. So next example, evaluate integration 0 to infinity x raised to 8 into 1 minus x raised to 6 whole divided by 1 plus x whole raised to 24 into dx. So you just relate this example to either definition of beta gamma or any property of beta gamma. So you can observe here, that is it relate to the second definition of beta. What is that? As the definition of beta function, integration 0 to infinity x raised to m minus 1 upon 1 plus x raised to m plus n dx. So note that here first means m power plus 1 and second, then once we get m, then this power minus m, so I will get n, second number. So I can relate this to this definition, and that is why solution, let I equal to integration 0 to infinity x raised to 8 into 1 minus x raised to 6 upon 1 plus x raised to 24 dx. If we simplify it, so I am getting integration 0 to infinity x raised to 8 multiply inside, so I am getting x raised to 8 minus x raised to 14 whole divided by 1 plus x raised to 24 dx. Same thing I can write as integration 0 to infinity x raised to 8 upon 1 plus x raised to 24 minus x raised to 14 upon 1 plus x raised to 24 into dx. So what is I here? Integration 0 to infinity. So by properties of definite integral, I can separate it. How? So I am getting here I equal to integration 0 to infinity x raised to 8 upon 1 plus x raised to 24 into dx minus integration 0 to infinity x raised to 14 upon 1 plus x raised to 24 into dx. You can see here the definition of beta function. So by this I can find out. So I am getting here I equal to beta. So this power plus 1. So first number I am getting 9 and 24 minus 9 I will get the second number, and it is nothing but 15 minus beta power plus 1. So 14 plus 1 I am getting 15 and this second number I will get this power minus the first number. So I am getting here 9. And as the property of beta function, that is the beta of mn equal to beta of nm, both are same. So I am getting I equal to 0. And therefore, integration 0 to infinity, what is I this? So x raised to 8, 1 minus x raised to 6 upon 1 plus x whole raised to 24 dx, that is equal to 0, which is your required answer. So example, show that integration 0 to infinity x raised to n minus 1 upon a plus b x whole raised to m plus n dx equal to 1 upon a raised to m b raised to n into beta mn. So can you relate the given thing to any one, either the definitions of beta and gamma or properties of beta and gamma? If yes, then this problem is very easy. So let's see how. So by this one, 0 to infinity, I can relate the second definition of beta. So first of all, let this I equal to integration 0 to infinity x raised to n minus 1 upon 1 plus a plus b x raised to m plus n into dx. So what is the substitution there? As we compare here beta of mn definition, integration 0 to infinity x raised to m minus 1 upon 1 plus x raised to m plus n dx. It means that here I want 1 plus x. Here I want 1 plus x, just like 1 plus x. How? And that is why substitution is there. Bx equal to at. So what is x? A by b into t. And therefore dx equal to a by b into dt. What about the limits x to t? So here x, here t, given limits are 0 to infinity, and that is why if we put x equal to 0, so I will get here t equal to 0, and infinity, as x tends to infinity, I am getting t tends to also infinity, and therefore I equal to integration 0 to infinity x, what is the x here? A by b into t raised to n minus 1 whole divides a plus, what is the bx? It is the at now, raised to m plus n into dx, and dx is a by b into dt. Now simplification. So simplify this, take all constant terms outside. So I am getting here I equal to here a by b raised to n minus 1 into here a common raised to m plus n. So 1 upon a raised to m plus n into a by b. Integration 0 to infinity, here t raised to n minus 1 upon 1 plus t raised to m plus n into dt. So what is the power of it? What we want to prove? We have to prove this is 1 upon a raised to m and the b raised to n. So that is why I want a in denominator. So what is the power of a here? In denominator, if it is in numerator, so in denominator it will be minus n minus minus plus 1, means minus of this one. Now this is already in denominator, so m plus n, and here a, but in numerator, that is why in denominator it is a minus 1. So simplify this, so this plus n minus n get cancelled, minus plus 1 get cancelled, so a raised to m I am getting. So I equal to 1 upon a raised to m. What about b? So you can see here b raised to, it is already in denominator, n minus 1 and one more b there. So plus 1. So I am getting b raised to n. So b raised to n into beta. So by this beta power plus 1. So n minus 1 plus 1. So I am getting here n, and this power minus n. So I am getting next number is m. And as we know, beta nm equal to beta mn. So same thing I can write I equal to 1 upon a raised to m b raised to n beta of m n. And therefore, what is I? So, I is nothing but integration 0 to infinity x raised to n minus 1 upon a plus bx raised to m plus n into dx, and that is equal to 1 upon a raised to m b raised to n into beta of m n, which we want to prove. Example, prove that integration 0 to infinity dx upon 1 plus x raised to 4 equal to pi upon 2 root 2. Again the same thing. If you can relate this to any one, means definition of beta and gamma or property of beta gamma, problem finished. Then you will get easily the substitution and then only the simplification, you will get the required result. So let I equal to integration 0 to infinity dx upon 1 plus x raised to 4. Note that here relate to second definition of beta, it is a x raised to m minus 1 upon 1 plus x raised to m plus n dx. So here I want to single, means here variable with power 1, and that is why substitution is very clear, x raised to 4 equal to t, and therefore what is x? It is a t raised to 1 by 4, and the dx equal to 1 by 4 t raised to 1 by 4 minus 1 means minus 3 by 4 into dt. What about the limits? X to t, you take here limits x to t, so 0 to infinity given limits, and now if we put x equal to 0, I will get t equal to 0, x is infinity, t is infinity. So no change in the limits. Now simplify it. So I am getting I equal to integration 0 to infinity dx, it is a 1 by 4 t raised to minus 3 by 4 dt whole divides 1 plus t. So simplify it. So I am getting I equal to constant term 1 by 4 outside, integration 0 to infinity t raised to minus 3 by 4 upon 1 plus t into dt. So you can observe here it is a beta, but how to write? So by definition of beta function, here this power plus 1 I will get the first number, and second number this power minus first number I will get second, and therefore I am getting here I equal to 1 by 4 beta this power plus 1. So it will be 1 by 4, and what is the power of this? It is a 1. So this 1 minus first number, so I will get here 3 by 4. So how to evaluate this beta 1 by 4, 3 by 4? So whenever beta there, you convert into gamma by using the relation between beta and gamma. So I can write here I equal to 1 by 4 gamma separation upon gamma addition. So what is the addition of these two? 1 by 4 plus 3 by 4, it is 1. So gamma 1, and gamma 1 is 1. So that is equal to 1 by 4 gamma 1 by 4 gamma 3 by 4. Note that here one may ask example as find the value of gamma 1 by 4 gamma 3 by 4. Maybe one MCQ on this. So how to evaluate this one? So here you have to use property of gamma function. What is that property? Since gamma p gamma 1 minus p equal to pi upon sine p pi, when p is in between 0 to 1. When I can use this, because 1 by 4 plus 3 by 4 it is 1. Here p plus 1 minus p, it is 1. So I can use this, and that is why I am getting I equal to 1 by 4, it is a pi upon sine p pi. So what is a p? Here p is 1 by 4. 1 by 4 into pi means it is a pi by 4. And by standard value of sine pi by 4, it is a 1 by root 2. So simplify this. So I am getting I equal to 1 by 4 pi upon 1 by root 2. So this is equal to 1 by 4, and this will be pi root 2. Now simplify this 2, I can write as a 2 into 2, and this 2 I can write as root 2 into root 2. and this root 2, 1 root 2 get cancelled with this one. So therefore, I am getting I equal to pi upon 2 root 2. So what is I? So I is nothing but here you can see integration 0 to infinity dx upon 1 plus x raised to 4. So I am getting here 0 to infinity integration dx upon 1 plus x raised to 4, and that is equal to, we got pi upon 2 root 2. What we want to prove? The same. So this is your required answer. The next example, prove that integration 0 to pi by 2 d theta upon under root of sin theta into integration 0 to pi by 2 under root of sin theta d theta equal to pi. Here you should know which property we have to use. So let's see here. So let I equal to integration 0 to pi by 2 d theta upon under root of sin theta into integration 0 to pi by 2 under root of sin theta into d theta. Same thing I can write as integration 0 to pi by 2 here sin theta raised to minus half into d theta, because here under root means it is a power half, it is in denominator, so in numerator it is a minus half into integration 0 to pi by 2, here I am getting sin theta raised to half d theta. As we know, property of beta function is a integration 0 to pi by 2 sin theta raised to p cos theta raised to q d theta, actually there should be d theta equal to 1 by 2 beta of p plus 1 by 2 q plus 1 by 2. So for that I want power of cos. So here same thing I can write as integration 0 to pi by 2, here sin theta raised to minus half. But what about cos? So it is a cos theta raised to 0, and here integration 0 to pi by 2 sin theta raised to half and cos theta raised to 0 d theta. So I am getting here, it is a, by using this value it is a p plus 1 by 2. So I am getting here it is a 1 by 2 beta of power means minus half. So minus half plus 1 by 2, 0 plus 1 by 2. For second, it is also 1 by 2 beta of 1 by 2 plus 1 by 2 and 0 plus 1 by 2. So simplify it, you will get the required answer. How? So that is equal to 1 by 2. Here I am getting beta. This minus half plus 1, it is half by 2, 1 by 4. Here 1 by 2 into 1 by 2 beta, it is a half plus 1, 3 by 2 by 2, it is a 3 by 4, and here 1 by 2. So again the relation between beta and gamma function, so separate. So I am getting here 1 by 2 gamma 1 by 4 gamma 1 by 2 upon gamma, means gamma separation upon gamma addition. So 1 by 4 plus 1 by 2, it is a 3 by 4 into 1 by 2 gamma 3 by 4 gamma 1 by 2 upon gamma 3 by 4 plus 1 by 2, it is a 5 by 4. So this gamma 3 by 4 get cancelled. If we simplify it, so I am getting here, this is 1 by 2 and this 1 by 2, it will be 1 by 4. Here gamma 1 by 4, this gamma half, here gamma half, so root pi, gamma half is root pi. So root pi upon gamma 5 by 4. Can I write here this gamma 5 by 4 as gamma 1 by 4 plus 1? And therefore, I can use here the property of gamma function, which is this property, since gamma n plus 1 equal to n gamma n. And that is why I am getting here 1 by 4, this gamma 1 by 4, root pi, it is a pi upon this one. Now I am using here the property, it is 1 by 4 gamma 1 by 4. So you can see this gamma 1 by 4 get cancelled, this 1 by 4 get cancelled, and that is equal to pi. What is the I? So I equal to integration 0 to pi by 2 d theta upon under root of sin theta into integration 0 to pi by 2 under root of sin theta d theta, and that is equal to, so I am getting here I means integration 0 to pi by 2 d theta upon under root of sin theta into integration 0 to pi by 2 under root of sin theta d theta, and that is equal to pi, which is your required answer. So evaluate. So next example now, evaluate integration a to b x minus a raised to m into b minus x raised to n dx. Again the same thing I will say. Can you relate this to either definition of beta gamma function or any property of beta gamma function? If yes, then you can evaluate it. So you can observe here the properties of beta gamma function as well as so definition of beta and gamma function. So you can observe here, by the definition of beta function I can evaluate it. For that what I require? See there, solution. Let this integral denote by I, integration a to b x minus a raised to m and b minus x raised to n dx. So if we relate this, so beta of mn equal to integration 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. It is I want here a variable and you relate with this one. So automatically you will get the substitution there. So how I want here one variable. So put x minus a equal to t. But due to this substitution, I should get here 0 to 1. If yes, then it is correct. Otherwise, some modification required there. So let's see here. When we put lower limit a, so x equal to a, so a minus a, I am getting t equal to 0. So it is a fulfill. But when we are putting here upper limit b, so I am getting b minus a, that is the t. So that is a t equal to b minus a is the upper limit. But that I want 1. So how to convert this b minus a into 1? So if we divide by b minus a by b minus a, I will get there 1. And that is why substitution is x minus a upon b minus a equal to t. And therefore you find the value of x. So x minus a equal to b minus a into t. So what is x? X equal to b minus a into t plus a. So what about dx here? So it will be b minus a into dt. And now you consider the limits x to t. Given limits are a to b. So x equal to a, I am getting t equal to 0. When x equal to b, so b minus a upon b minus a, it becomes now 1. So simplify this. So substitute these values in the integral. But before to that, you just simplify this b minus x. So b minus, what is x value? X is nothing but a b minus a into t plus a, and that is equal to b minus a into t minus a. Same thing, I can collect this b and this minus a together, and that is why b minus a minus b minus a into t. Common out b minus a. So I am getting here b minus a common, in bracket 1 minus t. So therefore b minus x I can consider b minus a into 1 minus t. Now substitute all these things in I. So I am getting I equal to integration 0 to 1 x minus a, it is nothing but b minus a into t whole raised to m and b minus x raised to n. So it will be b minus a into 1 minus t raised to n and dx, it is a b minus a into dt. So simplify it, taking constant terms outside. So I am getting here I equal to b minus a. So what is the power? Here I am getting power m, here I am getting power n, and one more b minus a, and therefore b minus a raised to m plus n plus 1. Integration 0 to 1, here t raised to m and here 1 minus t raised to n dt. So by definition of beta function, I am getting here this b minus a raised to m plus n plus 1 as it is, and here it will be beta m plus 1 n plus 1. So what is the I here? So I is nothing but this one, and therefore I am getting integration from a to b x minus a raised to m b minus x raised to n dx equal to b minus a raised to m plus n plus 1 into beta of m plus 1 n plus 1, which is your required answer. One may convert this beta into gamma function, that is the gamma separation upon gamma addition. Suppose here the numbers or any numerical values or particular values of m and n, then you must simplify this in gamma and then we'll get a numerical value. Now consider a similar example. Evaluate integration 3 to 5 x minus 3 raised to half into 5 minus x raised to half dx. So similar, that is why I know now what is the substitution here. So let I equal to integration 3 to 5 x minus 3 raised to half and 5 minus x raised to half dx. If we relate this with the definition of beta function, this is the definition of beta. So substitution is what here? I want single variable here, and that is why x minus 3. But when we substitute here 3, x equal to 3, I will get 0. But when x equal to 5, so 5 minus 3, I will get 2. But I want 1 here, and that is why I divide by 2 equal to t. Note the substitution here, and I am getting x equal to 2t plus 3. You can simplify it as x minus 3 equal to 2t. So what is the dx? It is a 2 dt. And what about the limits? As we know, x to t, x limits are 3 to 5, and therefore corresponding limits 0 to 1. So I equal to integration 0 to 1 x minus 3, it is nothing but now 2t raised to half, and 5 minus x, what is x? It is a 2t plus 3 raised to half, and dx is a 2 dt. So simplify here, you will get the final answer. So how? So I equal to integration 0 to 1 2t raised to half, and here 5 minus 2t minus 3 raised to half into 2 dt. So integration 0 to 1 2t raised to half, here I am getting 2 minus 2t raised to half into 2 dt. So common out the terms, so 2 raised to half here, here also 2 common, so 2 raised to half and 2 raised to 1. So half plus 1, I am getting 2 square. Integration 0 to 1 t raised to half, and here 1 minus t raised to half dt. So by definition of beta function, I am getting I equal to here 2 raised to 2 means 4, and it is a beta power plus 1 means half plus 1 3 by 2, half plus 1 means 3 by 2. By using property of beta and gamma function, that is the relation between beta and the gamma function, I can write gamma separation upon gamma addition. So 3 by 2 plus 3 by 2, it will be 6 by 2 means it is a gamma 3. So it will be 4, gamma 3 by 2 I know it is a 1 by 2 root pi, gamma 3 by 2 again 1 by 2 root pi upon gamma 3, it is a 2 factorial. So I am getting I equal to 4, this 1 by 2 it will be 1 by 4 into pi upon 2 factorial means 2. Simplify this, so I am getting this 4, 1 by 4 into 1 by 2 into pi. So it is the I equal to pi by 2, and therefore what is the I here? So I am getting integration 3 to 5 x minus 3 raised to half 5 minus x raised to half dx equal to pi by 2, which is your required answer.